So with TLS, as I said before, TLS is just an extension to SSL with minor differences. In the version number, obviously, it has been changed from 3 to 3.1, and they uses HMAC, which is the keyed MAC, and they use a pseudo-random function that expands the secret based upon HMAC during SHA-1 and MD5. So the secrets, we saw how they expand, right? They take lots of things, they concatenate them together, and then they do MD5. We saw the MD5, but could have been SHA-1 as well. Has additional alert codes, has some changes in the supported cipher, so there are some more algorithms, more encryption algorithms are supported, and certificate types and negotiations are done, more certificate types, and changes in the crypto computation and padding. We didn't go into the padding details here. Somehow we didn't go into the padding details, but that is different in TLS. All right, so TLS and SSL are same and almost same, but with some extensions. All right, and then we come to HTTPS, which is, again, we have already talked about everything that we need to talk about, because HTTPS is nothing but HTTP over SSL, and that means that you basically do whatever we talked about, and the main change is that now you use the port number 443 rather than 80. So with port 443, it goes through SSL. With 80, it goes straight to HTTP module. And with HTTPS, the URL, the document contents, the form data, cookies, HTTP, everything is encrypted. Anyway, so the summary is, every time you see HTTPS, you are doing SSL or TLS. So before you do HTTP request, you do TLS handshake, and before you close so basically you have to somehow enclose that, in the sense that you first open the TLS and then open the HTTP, first close the HTTP and then close the TLS, things like that. And then the question is, how do you close the TCP connection? TCP connection has to be closed after the SSL has been closed. Right? Everything has been closed, then you close TCP. Now, having said that, it is quite possible that the TCP may have to be closed abnormally. For something happens and the TCP connection cannot reach, something like that, right? So that case is handled. Must handle abnormal TCP close before alert exchange is sent or completed. Remember, one of the alert was close, and so that simply says that, look, I want to close the connection now, right? And which is a normal thing. It's actually not really a alert, but and that is just a normal thing, right? So so normally you close that connection and then you close the TCP connection. But if the TCP somehow closes before, that is also okay. Then basically we'll just close the SSL connection. Yeah. SFTP? Yeah. Okay, that is slightly different. So that would be FTP over SSL. Right? Now, FTP does two connections, control and data, right? And I am not sure, I mean, I have to read myself, find out whether it is required that you encrypt both, or you encrypt one, just the control part, and leave the data alone, or things like that. Here, that is not a choice. Here, in HTTP, the control and data are intermixed. There is only one connection, right? So that might be a detail that you need to look it up if you want to do SFTP. All right, then there is secure cell. So SSH, all of you have used SSH, I suppose. SSH is just a secure telnet, right? Remote terminal protected one. So SSH1, and now there is SSH version 2, which is what we use, and it is documented in these RFCs, and these are widely available, and we have all used it. So with that introduction, let's go through the protocols. SSH has 3 protocols. So they don't have change cipher spec, but they have 3 protocols. They have authentication. First, okay, so they have authentication, they have connection, and they have encryption. So this encryption thing is called transport layer protocol, And by the way, SSH is also a transport layer security. I mean, it's not called TLS, but it is also transport level security protocol. Right? I mean, TLS just stole the whole category name as one, but this is in the same category, transport level, because it works on top of TCP and it provides security. And just like TLS, it has two layers actually. The one layer which does the encryption and integrity, and but the keys etc. you have to exchange, you have to negotiate, and those are done by these two protocols. The numbers here 1, 2, 3 means in the order that we will discuss them. So number 1 we'll discuss. In this case, somehow I decided to just follow the book's order, which is the transport layer first. So if you know the keys etc., then all you have to do is set up the TCP connection, and then you have to specify what is the protocol version and software version, and this one specifies what the protocol version and software version. Then you negotiate the keys. Then once you have the keys, then you can start the this encryption, and the encryption proceeds as follows. You take the payload, compress it. After compression, you add the packet length and the padding length and add the padding, and you add a sequence number. And the interesting thing is that the sequence number is added and MAC'd, in the sense that when you calculate the MAC, the sequence number has to be added, but it is not sent. So it is not encrypted. Only thing you encrypt is packet length, padding, etc. You encrypt that much, and you add the MAC, and the MAC is outside the encryption. So it is encrypt and MAC. All right. And then you send this. At the other side, you have to do the same thing. You have to generate the sequence number, and if some messages are missing, obviously the sequence number will not match. Put the sequence number, check the MAC out, and check the encryption out. So the second thing is the authentication protocol, which consists of, very similar to the TLS, is that you actually, it's slightly different though, but basically the client says to the server, I want to authenticate, but I don't know what method to use. And so the server says, you are not authenticated, but I can accept the public key or password. It gives options of two methods. Then the client says, okay, here is my password, and I am selecting the method of password. And then the server says, okay, success. So there are 3 messages in this protocol: request, failure, and success. Again, this is kind of strange as to how this came about. Is that first you send method equal to none. They could have sent that, okay, I can do password, and just like we do in TLS, they could have said that I can do password, and then the server and certificate, and the server would select one of those. Right? Here, the server specifies and the client selects. And by the way, this is user authentication. So what about the server authentication? So the server authentication is fixed. Server authentication is always by its certificate. And what you do is, when you do SSH, very first time when you go to a server, you get their public key. Now, whether you want to trust that public key or not is up to you. So it will ask you, the user, it will ask you the user on the screen. So the key is this and that. Do you want to store it? And you say yes. I mean, what else will you say? Once it is stored, that becomes the permanent key. Then anytime you connect to that server, basically that's the public key. Right? So you keep a list of public keys, and in that list is this server key added, basically manually. And many of these decisions were like this because this protocol SSH was done by somebody on his own time, and he just started using it for himself or something like that, and then suddenly people found out and they said, oh, we like it, let's do it, So the whole history behind it. But anyway, so the server authentication is done by this key, which is the user just has to verify and accept. And then the client has to be authenticated every time, and so the client has to supply the password generally every time. Or it could supply a public key too. I mean, it could generate. So these are not really the certificates as such. These are not certificates supplied by, VeriSign and other people. You could just generate in your computer a private key and public key pair and send the public key. And again, the question is, how will they really verify, because there's no root, things like that. So that weakness exists. But basically, you can use just the password and authenticate yourself. Then you have to set up channels. So the way SSH works is that once you have set up this master connection, master pipe or whatever you want to call it, you can put many little channels inside it. And you can use it for different purposes. So there is a connection layer which allows you to do that. So it is used for multiple logical channels. And any site can open a channel. So this site can say, I want to open a channel number 2, and this site will say, I want to open channel number 3. And for each channel, basically, you open it, use it, and close it. Open, use, and close it. And there are 4 types of channels. One is for terminal sessions, the normal one, X11 session, which is the Windows session, and then forwarded TCP/IP and direct TCP/IP. That is for any other applications other than these 2. You could use SSH for any other application by forwarding their ports. And there are 2 ways of forwarding the port. One is called remote port forwarding, other one is called local port forwarding. The SSH name for remote port forwarding is forwarded TCP/IP, and then this is direct TCP/IP. And actually, next slide explains this. But basically, there are 4 types of channels that you can set up, and you can connect and disconnect, and so basically keep different channels separate inside a SSH connection. So by the way, if you do SSH, you can transfer files while inside the SSH sessions, right? So that is the kind of thing where you can use a channel. Now, port forwarding is not from the book, by the way. It was so confusing. It took me, to read lots of other sources to figure out what exactly is happening in the port forwarding. So I prepared this slide one time, and then I re-prepared it again last night. That's why I gave you the revised handout. All right, so listen carefully this one. Basically, what port forwarding allows you to do is that once you have set up the SSH tunnel, then you can use any application which is not secure over this tunnel. So that will be secured. Any insecure application can be used over SSH tunnel. There are 2 ways of forwarding. So basically, one way of forwarding is that, let's say you are doing mail service. You want to read your mail at the work when you are at home. Host H is home, host W is work. So you SSH to work, and then you can do terminal. Anything you can do on the terminal, you can do in the SSH window, right? But let's say you want to read the mail, and you want to read encrypted mail. I mean, you want to encrypt it so that anybody outside of your company or on the way cannot read it. So then what you do is you forward the port. Basically, what you do is you tell the other side that, look, everything that I send on this channel that I'm setting up, new channel, please send it to the host S in the company on port Y. That is where my server is for the application. Host S Y, that is written as S:Y. S is the IP address, Y is the port number. And you tell the application on this side that your server is located on host H at port host H at port A, host H at port A. So instead of this one, when it generates a message, instead of sending it to SY, it sends it to HA. And obviously SSH is listening on that port. SSH is listening like any other server can listen on TCP port. SSH is listening on A. So whenever application sends it, SSH gets that message locally by a local loopback. It goes to TCP and it comes back to SSH. Then it puts it into this logical channel. It goes there. There it is decrypted and then sent to host S on port Y. And so now the host S doesn't really know that this message was encrypted along the way or that it came by SSH. All it knows is that it came from application here. Basically it could have, if they would have connected directly, they would have just gotten the same set of messages, right? But those messages would have been in clear. Now these messages are all encrypted on the internet. So now you have to understand the two things here. First of all, first is the port numbers. So the X is the port number for this application that it is sending. This is the source port number. A is the destination port number, right? Here B is the source port number, C is the destination port number, which is generally 22. For SSH, the destination port number is, for SSH server, the standard port number is 22, right? C is 22. D could be any number, and Y is whatever this application is listening on. So if it is FTP server, it is listening on port 21. If it is a mail server, it is listening on some port number, right? So those Y is standard and C is standard, but everything else can be any number here. And the arrows are not really meaningful, but all TCP connections are bidirectional, right? But the arrows simply show the direction of the connection request, TCP connection. So this application starts request a TCP that I want to set up a connection with port A, right? So that is why the arrow is shown like this. And here this SSH requests the TCP that I want to set up a connection with host S on port Y. Okay, so the arrows are simply for the connect request. And very often the application doesn't really rely on some other host. It could be right on the same host as the SSH. If that is the case, then you don't say SY, you say 127.0.0.1Y, because 127.0.0.1 is localhost. Oftentimes, if you have used SSH, this is the kind of command you give. You say, I want to SSH to host W, but I want to do the local port forwarding such that my port A is forwarded to host, generally you will write localhost here, :Y port, that port. I like the word LOCALHOST is put there instead of S. And the word L means I am going to start from this side, from the local side. The other alternative is that somehow your company does not allow you to SSH from outside, your firewall prevents you, then you can start the SSH from there, from the company, and come home. In that case, the SSH connection goes like that. However, you also say that basically I am going to do the port forwarding here. You tell the home computer that I will forward your A port to the Y port here. So that is called remote forwarding. So the main difference between local and remote is very subtle, very different, is that in the local forwarding, the client starts the SSH, and then the client tells the server, the other side, that please forward the traffic to Y, right? In the remote forwarding, host W is the client, by the way. Okay, so don't get confused. This is the client and this is the server, right? The client SSH starts the tunnel, which is host W, and informs the server SSH, which is host H, that I will forward the traffic on this channel to Y. I will forward the traffic. So this is I will and please forward. That's the kind of thing, Local means please do it, and this one says, starting point says, well, I will do it. All right? So if that is the case, that is the remote forwarding. And if you want to read all of this clearly, then this is described in this book, which somehow is online. I don't know why it is online. But the whole book is online, SSH for Dummies or something like that, name of the book is. So anyway, so this is about port forwarding. Left R. Where is R? Left A is this one.
L means local.
Yeah, L means local forwarding, R means remote forwarding. So when you start the SSH command, this is the SSH command you will do. This is the command you will run here on host H. This is the command you will run here on host W. And I should probably label clearly so that you know that this is a client and this is a server, this is a server and this is a client. Because people will normally think that this is always the server. So this is not the server, this is the client, this is the server, and that is shown by this arrow. The client always starts the connection to the server. And if in this example S is same as W, then this will be localhost. So you are on this host and you are going to say SSH minus RA colon localhost colon Y, and then space H. H is the destination. Exactly. So the thing is, when your firewall doesn't allow you to do this way, you just start from the inside out, and then you're going out of town or going to be home, and then you can connect it that way. Well, going out of town is kind of difficult, looks to me, because when you set up the tunnel, this host has to be up. And if you want to be in Germany and your host is not there in Germany, you can't really do from work, right? But for home you can do, because your home computer is up, it has a server running, it can accept the SSH connection, right? If you had a connection in Germany where your computer is already there, then probably this will work. But if you're going to take your laptop, it will not work. The laptop is not there to accept the connection. So this SSH tunnel is set up before you reach home, and then when you reach home, then you can basically start reading the emails or whatever you want to read. Now, the application doesn't know anything. So this is the interesting thing about SSH. That only thing application has been told, the only difference has been that this application at home has been told that the server is at this host port A. Normally, you have the server at, let's say for us it is mail.bushtel.edu port, I forget the port number. What is the port number for SMTP? Some port number, right? Instead of that, we say that no, it's right here on this host, and the port number is this. So that's the only thing that, so the server, you can just program your application to send all the requests to port A. Now TCP doesn't do anything special. Anything that comes to port A, it just delivers to port A. And on this side, you don't tell anything to the server. But anyway, the summary of this whole chapter is SSL is basically used with HTTP, and it provides the security at the transport layer. And so there are several protocols that we talked about at the transport layer. SSH is one of them. SSL is more common of them, right? So SSL is also called TLS because once the SSL became popular, they standardized it, and the standard version is no longer compatible with the old version, so it is called version 3.1. It had 4 protocols: handshake for negotiation of the crypto, change cipher. Anybody remembers what change cipher was for? So just one byte command. It simply says, let's use it now. Then the alert protocol, clearly for error conditions and or any other conditions which happen during the communication. And the main protocol is record protocol, which does the encryption and message authentication. So HTTPS is simply HTTP or SSL, so there is nothing special about it. It's just a new protocol port number. Then we talk about SSH, and SSH provides remote login, and again instead of 4, it consists of 3 protocols: authentication, which is very similar to the handshake, connection, and the transport. Transport is like record, and the connection is used to set up channels, for which there is no equivalent here. But basically, you can have many channels in a single connection, in a single SSH connection, and then some of these channels can be used for tunneling, where tunneling is the port forwarding. So you can forward some ports on a remote machine to SSH and make it protected. secure. Even if the application is insecure and does not require any change from the application, only thing is that the client has to send it to a particular port on the local machine, and then it forwards it from there. But anyway, there is a homework here, but it is still important to do this homework because these things will keep coming back and back and back.